welcome back to my channel. Starting from this video, I'll be doing a series of recursion solutions because I'm going through the recursion chapter. And today we're going to work on the question reverse string. Write a function that reverses a string. The input string is given as an array of characters S. You must do this by modifying the input array in place with O1 extra memory. For recursion, it's going to be O(n) extra memory, but I'm going to also go over the two-pointer solution in this video. So let's read example 1 as equals hello, and then output is hello backwards. This is a pretty simple question. So for the purpose of this question with O(n) extra memory, I'll go through the two-pointer solution first. So with two-pointer, we define left pointer at 0 and then right pointer at like this end index, which is length of s minus 1, because Python indices start at 0. And then while left is smaller than right, we can do in-place modification to reach this O(n) memory. So we do in-place swapping modification as left, as right equals s right, s left, and then all we have to do is increase the left pointer by 1. You want the left pointer to eventually go up, and you want to decrease the right pointer by 1. So then the right one will go this way, and then it keeps switches each time until you know it reaches the middle. Well, left is smaller than right, then it exits, and in the end we just return s because we did in-place modification. And let's try to run this. And for this solution, it would be a time complexity of O of n. It's actually, we're only going through half the characters in S because it's n divided by 2, but n divided by 2, n could be increasingly large, so it reduces back to O of n. And the space, since we're not allocating any extra space, it's O of 1. So this is the two-pointer solution. And we're done this, and I want to go back to the recursive solution. Because I'm doing a recursive series. Before I start, I just want to talk about recursion. Recursion is basically an approach to solve problems using a function that calls itself as a subroutine. So, to solve problems using a function that calls itself as a subroutine. So what does this mean? So each time a recursive function calls itself, it reduces the given problem into subproblems. And it continues until each subproblem, it continues until the subproblem can be solved without further recursion. And the recursive function has two basic properties. Number 1 is it has to have a base case. This base case is to terminate the function, to terminate the recursive loop, so it doesn't go on infinitely. And the second property is a set of rules that reduce all other cases towards the base case. Okay, so knowing this, let's start. This is like a brief introduction to recursion, and we'll start writing our recursive solution. So we can define a helper function within here, a helper that takes the left and right pointers. And let's say if left is smaller than right. Remember in the the two-pointer solution, we did while left is smaller than right. we do if left is smaller than right because we're solving this problem like case by case, like we're comparing it each time, versus iteratively, we just do a while loop. So in other words, recursion can be a replacement for iterative solutions or loops. It's just written differently. Instead of while, we use if. And then we do the swapping like we did. As left, as right equals as right, as left. Sorry, so this one is actually supposed to go inside here. If left is smaller than right, then we swap and then we call it again. And then in the end, we just initiate the recursion with left pointer 0 and right pointer at the end, length of s minus 1. Yeah, so this is how you would write the recursive solution. The complexity for this is time O(n). It's the same thing, it goes through half because it goes on both sides, so O of n divided by 2 reduces to O of n. And then space, because we're using a recursive stack, it's O of n also. Thank you for watching my video, and let me know if you have any questions.